start with the slide part of the presentation. DeepRacer, it is AWS's 1/18 scale race car. Does everybody understand the difference between AI, machine learning, and deep learning? Okay, so artificial intelligence is when we're teaching computers how to think. But it's also, it could go anything from looking at what time it is and then doing some automated fashion. And it's still technically a type of AI. When we get down into machine learning, we're teaching computers how to recognize when something happens that coincides with what we as a human has deemed to be important. So if we've deemed that being at work is on time, then the computer, through the machine learning process, will go through and determine the things that coincide with that and say, oh, traffic. Traffic is a big part on whether or not you wake up and get to work on time. Deep learning is whenever the machine figures out both things, that getting to work on time is important, and the data that coincides with it is also one of the key factors that determines that this happens. We are using in DeepRacer a type of deep learning called reinforcement training, and instead of creating an algorithm and letting it figure all of it out, we are providing a reward function that allows the computer to, at certain states, to determine whether or not it is advanced, or determine the state and how well it's doing at those individual states. And it compares those states together based on the decisions it's made in the past, and determines which one of those actions are better based on the reward it got for those states. It'll make a little bit more sense. Exactly makes sense. This is, I'm just defining the difference here a little bit better. As I said, it's to build machines that are capable of thinking like humans. Machine learning is to create computers that can solve problems on their own. And this is to, deep learning is to create machines that can discover the problems as well as the solutions. I will have all of these slides available on GitHub for you to download, and I'll share this in storage just in case you're wondering. And this talks a little bit more about how machine learning, you still have a human in the middle of the process, whereas deep learning you don't. So I'm going to let you see some really interesting information. This is Dr. Matt Wood at reInvent last year. He was introducing the DeepRacer, and he has some really interesting visuals in here on heat maps and how the computer was figuring out what the important parts, or how what the result of the computer trying to figure out what the important parts of the track were.
Good morning, everybody, and thank you, Andy. AWS DeepRacer is a fully autonomous 1/18 scale race car designed to get you rolling with reinforcement learning. You can train your racing models in the cloud and race them in a physical car against other developers in the AWS DeepRacer League. You can train your DeepRacer models using a simulated car and track running in the cloud. You can see here the track and the simulated view from the car's camera. This is a full 3D physics model of how the car interacts with its environment, all the way down to the tire pressure and friction on the texture of the track. DeepRacer learns by experimenting in the simulator. Under the hood, there are two neural networks being trained. The first detects features on the track. The heat map overlay shows what the reinforcement learning model is paying attention to, with red being the most important in making driving decisions. The second is the policy network. This is what makes decisions about when to steer left, steer right, or even accelerate. Once it's learned the basics, the algorithm starts to incorporate your reward function. This is just some Python code which tells you, the algorithm, what behavior to reward while optimizing for the fastest lap time. Finding the right rewards, like staying on the track and close to the center line, this is where the skill is in autonomous racing. Now, I won't spoil the fun and tell you all the tricks to rack up a fast lap time, except to say that speed is not as important as you might think. So let's take a look at this on our test track. We have here the DeepRacer on the start line of our official 2018 racing season track. It has a dotted line in the center of the track to help guide the car, but DeepRacer will navigate around this track completely autonomously. The view here is from the camera on the car, and we're having the same heat map overlay to show where the model is looking as it's driving. And we're going to run two models on the same car, each of which has spent a different amount of time training in the simulator to use a different reward. What we'll see is that with more track time and better rewards, the algorithm can learn more and more sophisticated driving behavior. Let's start with the first model. This is like a baby model. It's only spent about 40 minutes in the simulator, and you can see that it's very erratic. It's not very fast. The colours flickering in the heat map show that the model hasn't yet learned what to pay attention to. It just hasn't had enough time on the track. The model also uses a very simplistic scoring function. Okay, so that was the baby model. Now let's see what the Pro Racer version looks like in our second model. This has been trained with a more sophisticated reward function, which rewards correct track positioning and cornering with several hours of simulated track time to learn from. Let's fire her up. You can see this is much less erratic on the track. DeepRacer is driving more smoothly and deliberately. If you look at the heat map in the camera feed, you can see that the attention is much more focused. The reinforcement learning algorithm has been able to discover human-like driving behaviors, such as taking wide corners and aiming at the apex of the curve, which all result in faster lap times. Not too shabby. So before we move on, let's give a quick round of applause to our autonomous racer.
They get into the sales pitch after that. So the reinforcement training. Basically at the beginning when we kick off our model, we're going to initialize all of the environment. That's the EC2 and that's the Sumerian virtual reality, AWS Sumerian. We've got our TensorFlow, our SageMaker, and all of this sort of stuff firing in the background. Including we saw the RoboMaker map over here on the right. That's the one that gave us the bird's eye view of the car as it was racing. And then we're going to let the car, after we initialize all of our stuff, choose from a predetermined set of actions from a list based on the metadata that we put in when we configure our model. It's going to make a decision. That decision is going to result in a separate state. And that state is going to determine its reward. Once that reward happens, reward is some sort of integer. And the model under the hood knows that a higher integer is a good thing and a lower integer is a bad thing. It gets a reward, puts that into its learning model, and then it makes another decision. And it's millions and millions and millions of these stacked on top of each other. And that's how it starts to learn what the good behaviors are. Positive reinforcement is whenever the state that results is a good thing, something that we want it to do more of. So we give it a higher reward. This has a lot of benefits, but sometimes if all you're doing is adding more cookies or more points to the system, then it doesn't understand not to do bad things. It just does the good things more. For instance, sometimes you end up with a model that if you give it bonus points every time it's right over the center of the track, then it'll find a spot on the center of the track and it'll stop. And that's not what you want it to do. Think of these very much like kids or pets, and they will try and game the system. So make sure that your rewards compensate for that. Negative reinforcement, this is when we penalize for it not maintaining a certain standard. So unless it's moving forward, we're going to penalize it. This has some advantages as well. It's made a disadvantage if all you use is negative reinforcement, that you're only ever going to get behavior that meets the minimum requirement. So a good practice is to use some of both. Here I'm explaining the situation for the reinforcement training again. You have your agent. It's comparing it to a child that you're reinforcement training on it walking towards you. So the agent will perform an action, take some steps. Is it walking towards you or is it walking away from you? At the end of the action, the environment or the state has changed, and then you give the agent a reward based on that current state. If it walked away from you, you don't give it any cookies. If it walked towards you, then you give it a certain amount of cookies. Maybe you give it one cookie, I'm using the term cookie, one cookie for each step it took. But as long as you're consistent with how and comparatively you're giving the cookies, it really doesn't matter. You could give it 100 cookies for every step, but as long as that is in alignment with the amount that you get for other good things, then that's relatively good. But it doesn't matter if it's 100 or if it's a half a cookie, as long as it's relatively the same. So when you go to create your DeepRacer, this is the first thing that you'll see when you click on Create a Model. This basically talks about that same reward, state, action cycle that we have going on here. And you're going to be able to make sure that you have all of the appropriate resources that you need in order to do this. We need to pay attention to two key things: learning rate, entropy, and training time. Those are important metadata features that you'll be able to tweak as we go forward. Inside the action space, these things you can see at the beginning. The reward function is something that happens every time, and the hyperparameters you only do at the beginning when you're kicking off or only. I guess they're used throughout the model, but if you ever modify your model, you will not be able to modify your hyperparameters. You will be able to modify the reward function if you clone the model.
I think you can modify the hyperparameters. You can clone.
You really can? Okay.
Last time I checked, maybe they changed it.
That would be cool.
But it only affects the training. It doesn't matter for like you're not going to have a better model because you used different hyperparameters only. You might have less training time, you might coincidentally result in a better model, but it's not going to be like, oh, you used, a sharper knife or something.
And honestly, the defaults for the hyperparameters are a really good basic set until you start getting into really deep machine learning. You probably don't want to mess with those too much. Model name, model description, pretty standard. And this up here, make sure that you have all of the resources necessary. You'll get little red X's if for whatever reason you can't create these resources. I don't know if you've blocked certain services on your accounts or not, but I don't think anybody here should have had that. These are all the tracks that we currently can train on. Whenever we started on DeepRacer last year, there was one, the reinvent track, and then they opened the oval track really shortly after that, but then it was just those for a long time. And then they started slowly adding new tracks for quite a while after that. Let's see. This track right here is the October racetrack. So there's a race going on right now, and that's the racetrack that everybody's training their models on in order to try and win tickets to win. So this is the action space. This is what I was just talking about a little bit ago. There's two major things when we're talking about training the car, and that's what direction it turns, and that would be the degrees. So we have, if we say 30 degrees, we're saying the car can make a 30-degree turn to the right or a 30-degree turn to the left. And the steering angle granularity means how many slices do we slice that 30 degrees up in. If we say 5, then there's 5 different angles that it can choose from. If we say 3, then there's 3. And maximum speed is 12 miles an hour. That's the limit on the car. And the speed granularity, I believe, goes up to 3.
Does adding more options for all of these usually like increase the training time so as to, you know, do more combinations or permutations?
A very good question. Definitely the options here on your action list occur by, or the number of actions is your steering granularity times your speed granularity. So in this one it's 5 times 2, so we have a number of 10 options. In order for the model to train, it has to try each one of these a number of times. So the less amount you have, the more fully fledged your model will become quicker, but it also will be less reactive to the environment around it. So here's an example of having 7 steering angles and 3 speed granularities. So this tells us up there. So we've got 4 miles an hour, 8 miles an hour, 12 miles an hour at making 10 degrees to the right, 10 degrees to the left. And we've got every combination there in there. So this is 21 different things that it can choose between. And it takes a lot longer to train these models to be fully.
You will notice that it never creates an option for standing still though.
Yes.
So you don't have to worry about that.
Anymore.
Right.
Yeah.
Cool.
So this is the reward function. Everybody in here is familiar with Python, at least in the fact that they know that it's a programming language, at least?
Yeah, I use it a little bit with Lambda, but not,
Okay.
I'm not an expert, but.
Well, they do most of your work for you, honestly. There's this tab up here that says reward function examples, and there's also a lot of examples out on the AWS literature, so you can grab pieces and put them together. So it's a very easy way to learn Python. So this method is all that we're coding. So we are literally only coding 25 lines of code in order to make this race car. We get past parameters, which is a map, and this is how we get the little variables out of it. There's quite a bit of little variables. I have to keep looking them up. I think there's like 16.
There's a bunch.
Yeah. So this one is pulling out track width and distance from center. It's determining markers on the track based on the track width. So we're making a marker that tells us where you're 10% close to the center, where you're 25% off the center, and when you're 50% off the center. Now this is, remember, this is on each side, so we're doubling it. So when you're more than 50% off the center of the track, you are off the track. And then we base this reward here on whether or not you're greater than or equal to a marker. So if your distance from center is less than marker 1, which means you are closer than 10% to the center line of the track, then you are getting a full 1 cookie. If you are not closer than 1% or 10%, but you are closer than 25%, then you're getting half a cookie. And if you're somewhere in between 25% and 50%, you're getting a fourth of a cookie. Or a tenth of a cookie, sorry, 0.1. Else you're getting a really, really low number. There's a couple of ideas that you never want to actually give your reward function of 0, because it can create divide by 0 errors. Sometimes we can do it anyway. I haven't noticed any problems with doing it, but some people don't prefer not to do it. And this is a way to give it, it's like 0.0003.
So would that be considered as a negative reward if you get very, very little cookies? You get words as a negative, because I don't think you mentioned there's a line for like a negative reward in that particular example.
There's not really a negative reward in this one. This is the default one that you come into.
Right. I didn't know, have you ever figured out or been in a situation where positive and a negative rewards of both kind of need to be applied in the same?
I have, normally when I do negative rewards, I actually divide the reward by something. So I will multiply by 0.5, or I'll multiply by 1.5.
Okay.
That's
Yeah,
the
I think
way
I've
I
tried
would
a
do it.
negative reward. It didn't really happen. It wasn't like, oh my gosh, wow, now it's so much smarter.
So you just kind of set your own scale.
Yeah.
Yeah. This is, I pointed out earlier that there's some example functions. This is one of the example functions. This pulls out all wheels on track. And so it makes sure that all wheels are on track and that it's within 50% of the distance, and that gives you extra bonuses. This one is the prevent zigzag. So this one has a steering threshold. So what you're doing is you're basically overriding a little bit your action space and saying, I know I told you you couldn't do more than 15% angle, but if you are doing more than 15 degrees, sorry, not 15%, 15 degrees, then I want to multiply this reward down here by 0.8. So you're taking away 20% of its reward if it yanks the wheel to the right or to the left.
So that one's like the, your grandma's in the back seat reward function.
Yeah.
You can make a hard turn, but you're going to get complaints.
Yeah, exactly. These are the hyperparameters that I was talking about earlier. And you think you can change them in your notebook? We can check that out a little bit later.
Because I like to set them different for, like, I'll set up a simple reward function and build it up to more complex over time with different hyperparameters.
Totally cool. Learn something every day. So the gradient, in the next couple slides, I'll talk a little bit more about exactly what these do. But these are the defaults that you come in with, and for the most part, they serve me well. This is talking about the terminology that is used. We're getting really deep into a machine learning degree right here. Experience buffer, a batch, the training data is the set of batches sampled.
When you're running your reward function, do you have like access to previous states like as well? Like
No.
no, so
It's a snapshot, and you have the current information that came in from the sensors on your car right then, and that's all you have. And there's no way to save it off to try and compare it either.
yeah, like in that Python, so you can like a module level variable and like push them onto there or something.
I think that's intentional because you've got all this extra data when you're training that you're not going to have when it's running in the real world. Like it's not going to get an XY coordinate. There's no GPS on the, or maybe there is, but it's not using it.
Yeah, so you're not using XY coordinates.
Yeah, it doesn't know the track ahead of time, so all you're allowed to do is train the neural network to recognize, when I see this picture, here's what I should probably be doing. When I see a picture of a track turning left, I should probably start turning left.
And this just talks a little bit more about the other four. As I said, the slides will be available for download afterwards, so you can come back in and look at these specifically. This is the October track, so this is the one that you can start training on today if you want. Or the bow tie is the easiest one I've noticed, next to possibly the oval track and the reinvent track. And at every AWS event, or every significant one, the summits, the reinvents, the remars, and the reinforce, they hold DeepRacer races, and you can win various AWS stuff with these things. So this was the one that was held in New York.
You move your model between tracks? Or are you
Yes.
saving your model?
You can, but just be prepared that as you move it,
Oh yeah, you're gonna see.
and you can, I can
But
show
that way
you.
it's like overfitting your model to a specific track.
Exactly.
So,
I hope to see you guys.
Thank you. So Thursday?
Yes.
Thank you again.
And these are the links that I used to compile all of this data. And this is the QR code to give me my references, or to give me my feedback. And this is the GitHub, or GitLab, stuff that DevOps and my DeepRacer. So you can get my slides and you can get this, a couple of reward functions I have out there. So for this portion of the class, I was going to go around and help people work on their Pythons, whether or not they want to get started based on mine that are on GitLab, or if you want to start with the basic ones AWS gives you. I'm going to see if I can bring up one of the robo makers so we can look at this guy in 3D.
Finally got in, so.
Okay,
Yeah,
you ready to start?
yeah, sure.
Okay. Type in DeepRacer. Get started. You want to create the resources down there. No problem.
Have a good day.
You take care.
And do you know if there's just like cloud formation that creates this stuff?
It probably is a information on the template. It usually doesn't take more than 3 or 4 minutes. So.
Is it working for everybody? Is the Wi-Fi working for everyone but me?
Have you tried thing the website? Because it said no internet access, but then it let me in. It was strange, but
Like being on the website?
yeah, just like get online or yeah.
I mean, when I connect to the VMware thing, it says update server couldn't be reached, unable to connect to servers. So
Try google.com for.
Yeah, just on your regular laptop and see if you can get something that's not cached.
dinosaurs.
Well, I can't get onto it either on this one. You see what I can do on this guy.
I can try rebooting. That fixes everything, right? Where do I find it?
So once we have it open, should we just like try start training like with one of the samples just to see how it goes?
Absolutely, that would be totally cool.
Does it provide a lot of feedback so that you can see how they go?
Yes,
Okay.
yes, you'll get to one of the feedback screens, similar to the one that I'm trying to show you up here, but I'm having connection issues, so kind of got a freeze frame on it.
Okay.
You'll get 2 lines as you're training here. This is going to be a live video of what your car is seeing. It's always been a very laggy, it's just AWS. They're trying to not charge you a lot of money, it's not a Kinesis stream or anything like that, so. Because they're using the cheapest resources, it's really laggy. This purple line down here, this is how much percentage of the racetrack that your race car completed during that particular iteration. And the blue line up here, well, it depends on where yours is. I generally do 15 to 16 points per good thing. So that ends up being around 600 reward points per run. So that's where my line is way up here. So this is my reward functions. The key point that you'll want to make sure to take between these two is that the graph design looks pretty much the same thing. So you want to make sure that when your rewards are going up, your track completion goes up. And that when your rewards tank, then your track completion is tanking. So that way you know at least that you're lining up good rewards to good behavior and not so good rewards to not so good behavior. There are scatter plots here that you can turn on. I'm not sure if they're deleted, but they cache that information for me. So the lines are averages. The dots are the actual individual events. So I actually got a 95% track completion up here.
You can download your model, that's really cool too.
Do what?
You can download your model.
Mm-hmm. And downloading your model is how you actually put it on the card. So if you actually get a physical car, you have 2 batteries. This blue battery right here runs the drivetrain, and this battery runs the Linux computer right here. I believe it runs Ubuntu, or is it SUSE? It's a version of Linux. And you can use any of the USB devices, put in a keyboard and mouse and monitor. There's an HDMI cable right here for the monitor.
How do you get one of those?
AWS on Amazon. I got mine from reInvent last year. This is technically a developer edition. The professional editions, the real consumer editions, are the ones that people bought last year, but they only started shipping in the last month. So I've had mine ran mine into a bunch of walls, broken some shots on it already. So this one's seen a little bit of up and tumble.
How much does it cost?
400 when I
yeah.
looked at it.
Oh,
Yeah.
It fluctuates a little bit. If you bought it right out of the gate, I think you could get it for $250, but now they're running around $400. But as I said, it's an actual computer. So.
Right. You don't actually need one in order to be able to go through the simulations and get your coach a good point to be able to compete.
No,
Yeah, you can do the virtual races
Right.
no car.
Yep.
Cool.
If I could actually log in, I would show you how you can submit to a virtual race.
So it's just kind of fun, you can create your own track and throw it on there, see how well your model does.
Yeah.
Scale it, but it's like 1 point on there.
If you turn on that's because your batch size, and you only went through 1 batches. Flip on those little guys right there, and then those are your actual individual runs.
Okay. I guess I'm still like stuck on the state thing. Like whenever I'm driving like a real car, right? Like if the distance between you and the car is the same, right, and then it starts increasing. Like if I know that the car in front of me is like driving faster, right? Like it depends if I'm on like a stop sign, right, or like You know what I mean? Like, if I see that distance close, I don't slow down even if they're not braking, because they get like downshifting. So, like, is there any thing similar for like this, where like, if I know I saw like a sharp curve this way before, and then like a cutback, I know to do a quick maneuver for that, you know, versus like waiting to try to cut back and switch back, like, you know what I mean?
I totally understand what you're saying.
Yeah.
But you're in the mindset of still trying, I'm going to tell the car what to do.
Okay.
And it's very hard to let go of that idea. That's the basic machine learning, not the deep learning mindset.
I guess, but even with that, like, can't the computer figure out that, like, just more than the current state is important, right? Like, could it not figure out on its own that, like, oh, if I've seen this and I've seen this, then I should do this. Like, this is actually more efficient than just, you know what I mean, looking at one.
When you say it's seen this before, though, that's data that it's had and been trained on, right?
Well, no, I'm saying, like, if, like, let's say you had a 10 frame buffer of the camera, right? And it was using all 10 of those frames, right, to make decisions.
Inside of a particular state.
Yeah, so like, it's literally just moving, like, so frame at this time is to move it to the next spot, and then that one moves next, like, as it gets new state, right? So you have like the last 10 frames of the camera, right? And it's using all of that to make decisions.
You're totally right, but do you want to program an image recognition algorithm?
Oh, no, I just.
So
like,
yeah, I mean, that's why it's this way.
Okay, I just didn't know, like, if that was something that.
You could, because remember they gave us the like cheater instructions for how to build your own DeepRacer.
The jailbroke version?
Yeah, that thing.
Yeah,
like if you wanted to try that, you could probably design your own implementation of DeepRacer that uses the same fundamentals, but it trains it in the way that you're describing, where you would have access to past states and stuff like that. You're not going to submit that to virtual races or anything, because that's not like a official thing, but yeah, it sounds cool.
The guys that know, like,
you would be using like a recurrent training model where